Before we look at prime factorization, I want to briefly look at keywords that will help us to understand that concept. So the first keyword is factors. Now, factors are numbers we can multiply together to get another number. Now, if we want to find the factors of 12, we can think of pairs of numbers that we can multiply to get 12. For example, 1 times 12 is 12. 3 times 4 is 12. 6 multiplied by 2 is 12. And therefore, we can say the factors of 12 are 1, 2, 3, 4, 6, and 12. Another keyword that we need to know is a prime factor. Now, a prime factor is a factor that is a prime number. For example, if we have this product, 2 multiplied by 3 is equals to 6. Obviously, from year 7, you know that 2 and 3 are prime numbers. But they're also factors of 6. Therefore, we can call 2 and 3. We can say that 2 and 3 are prime factors because as much as they are prime numbers, they are also factors of 6. A multiple is a result of multiplying a number by an integer, and of course that integer has to be a whole number, not a fraction. So if you want to find multiples of 3, think of the 3 times table. So 3 multiplied by 1 is 3. 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. 3 multiplied by 4 is 12. 3 multiplied by 5 is 15. So you have a list of these guys here. And these are what we call multiples of 3. So multiples of 3 are 3, 6, 9, 12, 15, and so on. A prime number is a whole number with exactly 2 factors, 1 and itself. So only 2 factors, 1 and itself. 1 is not considered a prime number. So basically, if I want to list prime numbers, I'll start with 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31, and so on. Now, I want to start looking at prime factorization. Prime factorization is a process of finding which prime numbers multiply together to make an original number. So you'll be given an original number and you have to find prime numbers which multiply to get that number. Here is an example. Write 60 as a product of its prime factors. So we can use a factored tree. Now think of what 2 numbers can I multiply to get 60? Any 2 numbers. For example, 10, and 6. And then we want to keep on thinking of numbers that we can multiply to get each of these guys until we end up with the prime numbers. So here we'll end up with which two numbers can I multiply to get 10? That will be 5 and 2, and these are prime numbers. Just write again, 5 and 2. Here I will end up with 2 and 3, and these are prime numbers. So if we want to write 60 as a product of its prime factors, we'll end up with this. 60 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5, which can be written as 2 squared multiplied by 3 multiplied by 5. Here's another example. Write 300 as a product of its prime factors. So we'll use a factor tree. And then we'll end up, or we can summarize this by saying 300 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 5, which can be written as 2 squared multiplied by 3 multiplied by 5 squared. Okay, suppose you want to come up with another possible factor tree for 300. We can do that. So we can start with 300. Now, instead of 10 and 30, we can use different numbers. 300 is a multiple of 2, so we can start with 2 here. Then we end up with 150, 275, 325, and then 5 and 5. I can circle these guys. So, if we want to write 300 as a product of its prime factors, we'll end up with 300 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 5, which is 2 squared multiplied by 3 multiplied by 5 squared. And you can see that the answer that we have here is the same as the answer that we had in the previous question. So it doesn't matter which factor tree you use, you still end up with the same answer. Now, you can use the ladder method to write 300 as a product of its prime factors. This is just an alternative method to factor tree. So I'll show you how it works. You start by drawing the ladder. So if we start at the top here, you write 300 there. Now, think of a smallest prime number that you can divide by 300. Of course, 300 is a multiple of 2, and 2 is a prime number. So I can write 2 here. Now, 300 divided by 2 is 150. Again, 150 is a multiple of 2. So I can write 2 here. 150 divided by 2 is 75. Now 75 is a multiple of 3 and 3 is a prime number, so I can write 3 there. 75 divided by 3 is 25, so we have 25 here. 25 is a multiple of 5 and 5 is a prime number, so I write a 5 there. And then of course 25 divided by 5 is 5, so I write 5 here. And then I can divide 5 by itself and end up with 1, so we'll have 1 here. Now, how do we use this to write 300 as a product of its prime factors? Now, if you look at the left, all these guys here, the left here, they are prime numbers. And these are prime factors of 300. So you can summarize our solution by saying that 300 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 5, which is 2 squared multiplied by 3 multiplied by 5 squared. And again, you can notice that we actually end up with the same answer as what we had in the previous 2 questions. So these are all different ways on how you can write a number as a product of its prime factors.